All right, guys. So since I didn't have the recording on, I'm just going to review this really fast. I'm sorry for you guys for actually doing it live, but this way you guys have it to review later. So first thing we want to do is our power rule. I'm just going to do this really fast because I've already done it. I do my power rule. That's supposed to be a 3. ln x minus 1. I see this negative here, which is my quotient rule, which means this is going to end up being ln. It's 1 ln 2, 3, and the quotient means this gets divided. You can put a parentheses or you can not put a parentheses, doesn't matter. Next one over here, what we're going to do is first thing I see here is I see that there is a product, so that turns into adding. So I split this up. Next thing I do here is this 1/2 is actually a power of 3, or this square root, sorry, is a power of 3. I also see that this power of 3 can go to the front, so I'm using my power rule to put it in the front. We kind of saw that Admentum actually did something good this time, and they said, let's leave this 1/2 here in the front, but this division, we're going to use a quotient rule to subtract this out. And then what we're going to do here is we're going to distribute that 1/2 to make it this expression right here. This 3 log x plus 1/2 log w minus 1/2 log y. And the reason why I circled that is because I'm just saying that I'm distributing this 1/2 right here. Cool. So that should catch up the recording to where we're at. You guys are probably going to have to rewind that a lot if you guys watch that on YouTube later. All right. Everybody good? All right. So the next thing, this wants us to solve for x. So remember, ln is log of e. So that means we're going to raise this to the power of e. Raise all of it. Well, first things first, one thing I notice here is like, wait a minute. I can't raise this to the power of e because they're not one thing. So what I'm going to do here is I'm going to do ln of x plus 3 equals ln of 10 divided by x. Now I can raise everything to the power of e. E ln, or I should say base it. I keep saying raise it to the power of e, but really I'm basing it. I'm adding a base of e. So I'm going to do my base e. The base cancels out with the ln, so I get x plus 3 equals 10 divided by x. All right, so now I want to get rid of this x, so I'm going to multiply everything by x. So I get x squared plus 3x equals 10. Or in other words, x squared plus 3x minus 10. What do you guys think we have to do from here to solve for x? Any guesses? Okay, sorry. I did this really fast. Anybody have any guesses of how we're going to solve this quadratic? There's two things that should pop into your mind when you see a quadratic. One of them is remembering that there's a formula named after it. The other one is, it starts with a B. You guys want to take a guess at how we solve this? Yeah, we're going to factor it. Exactly. And there's two ways of factoring it. We can kind of like try to fill it out. I like using the box method myself, but yeah, we're going to factor this. So I'm going to use the box method because that's how I like factoring. You guys can use however way you want. So I'm going to figure out x and this. So I do an x, x. I'm going to try to figure out this 10. I want to get this 3 in this middle. So what I'm thinking, since it's a positive 3, I'm going to try doing a positive 5 and a negative 2. That's going to give me that negative 10, but more importantly, negative 10x or negative 2x and positive 5x gives me that negative 3x. So this ends up giving me this x plus 5, x minus 2. So yeah, we do factor it, and from here we get x equals negative 5, x equals positive 2. Does that make sense, guys? Nick, did you catch up? Cool. Do you do your box and everything too? Well, your box is right there. I mean, you can just write down your answers, but if you look at what Edmentum says when we answer it, they just factor it out. They don't show how, but remember, you should know the box method. I would hope you know the box method, Nick, after all that time we spent in Algebra 1 doing the box method. Did Miss Anush teach you guys the box method? Sorry, I feel like I'm excluding like Lily and Andy by asking that question. Did she guys teach you guys the box method? Oh, okay. She brought it back up. Or did you guys use that X method? I think he called it the area method, and then you guys told him to call it the box method. You're like, oh, like that was like pre-COVID. There's no memory before COVID. All right. Anyway, so one thing that we learn about logs, I think I've mentioned this before, but it's this idea that you can't have negatives and it can't be equal to 0. If we were to plug this into a calculator, so let me go to my little free calculator on Google here. If I type in ln of negative 3, for example, it's going to say error. And if I type in ln of 0, it also it says negative infinity, which there's no such thing as infinity. That's why Admentum calls it error. I'm actually impressed by Google saying it's negative infinity. This is a pretty cool little calculator for it being free. The reason why it says that is if we're at 0, it wouldn't connect until negative infinity. But negative infinity isn't a real number, it's a theory. So that's how come it says error on Admentum side. I'm impressed by Google now. So one thing we're going to learn, I kind of showed you this already, is this idea of changing the base. Changing the base is what we use to kind of use that free Google calculator. Is instead of it being like base 5, what we're going to do is we're going to do it in the way where we're going to do log of x to the 5 and log of 10 here. So that's all we're doing here. We're kind of like splitting this up in a way. We're doing it log base 10. So that's what I said when, remember, log base 10 is just this log parentheses. So this is a good strategy for figuring out how to do this on a calculator without having to do this. So the way I always remember it is log of the big number divided by log of the little number. Log log of your So if it goes like this, log of a base and argument, this is the same thing as saying log base 10 or log parentheses a divided by log parentheses of b. That's all this slide is talking about. And you can do it with anything. You can do it log base 2, log base 2. You can do it with ln. You can do it as ln of a divided by ln of b. whatever you want to do. This method is just useful because you can plug in your logs into your calculator here, or you can do ln because ln is also on this calculator. So Edmentum looks like it's very Google friendly. And here they're doing the exact same example, but with ln. And you can see they got the same answer. We have this answer there, and we have this answer there. Same answer. So now they're going to teach us how to do this, solving it with general letters, which I already showed you guys. It's just log of your big number, log of your argument, divided by log of your base. That's all we're doing. Except they're making it general. It can be with any base log, not just base 10 and not just base e with natural log. Is that making sense, guys? Cool. All right. Then this is how we would do it in a calculator. So if we're doing log of 7 or log base 7 of this argument of 20, we're just going to do log of 120 divided by log of 7, and that's how they get this here. So in theory, to check our answer, we would take this number and go 7 to that power, and it should give us this. So this is just a whole section that's teaching you how to do it friendly. Okay, so let's say we wanted to solve for this. Well, it's really hard to do because it's asking us 6 to what power gives us 25. Can't really do that, right? So what we're going to do when we write this down in our equation editor, it's a fraction. We're going to do log parentheses. Our big number is 25, so our argument is 25, and our little number is 6. And this is going to be equal to, let's go to Google here, clear this out. Log of 25, close my parentheses, divided by log of 6. And I get this, I'm going to say 1.8 because if I round, I wanted to do 2 decimal places, but if I do that, it becomes 80. So I guess 1.80 just to show that I did round it correctly. Let's say I wanted to do this with ln, it would still work. Ln of 25, close my parentheses, divided by ln of 6. I still get that 1.8. And this next one, we're asking what happens here. We're doing ln of x and this. So again, when I want to write this down on my calculator, I'm going to do log of 0.14 divided by log of 7. Go to my calculator. I'm just going to use ln just because I can. And then ln of 7. So make sure if you're using ln, you have to use ln for both. If you're using log, make sure you use log for both. Either way, you should get this negative 1.01. And according to Edmentum, because I'm a teacher, it can just show me the answer, 1.01. They use a lot of decimal places. Feel free to do that if you want. So now if we want to solve for this one takes a little bit of steps. First, I want to get rid of this 2. So I'm going to divide by 2. So then I get ln, log of 3, 2x equals 3. Well, I want to get to this x right here. So in order to do that, I have to get rid of this log. So what I'm going to do is I'm going to base it by 3, which makes 2x equals 3 to the 3 is 27. If you don't believe me, 3 times 3 is 9, times 3 again is 27. And then we're going to divide this by 2, divide by 2, and we get x equals half of 26 is 13, half of 1 is 0.5. So our answer is going to be 13.5. And here you can see their work all the way down. Now we're going to do this really big one. Well, one thing that I noticed is, check this out. All of them have the same base. So if they all have the same base, what I can do is I can combine this by using my quotient rule and my product rule. So this is the quotient, this is the product. So this becomes log of 5, 3x plus 10 divided by 4 equals log of 5, 2 times x. Well, since they're both the same base, I'm going to base this by 5. That cancels this out, cancels that out. So I get this. Let me go switch my pen. 3x plus 10 divided by 4 equals 2x. I want to get rid of this 4, so now it's just algebra from here. So this is going to get me 4's cancel out. 3x plus 10 equals 8x. Going to subtract my 8x, going to subtract my 8x. I get 10 equals 5x, so x equals 2. Does that make sense, guys? Am I going too fast, by the way? No. All right. Okay. Also, too, if I am going too fast, guys, and you don't want to like say anything, remember, I did record this one. It is recording, right? Let me double check. It is recording. It recording confirmed. All right. What's that? I clicked on the wrong thing. All right, cool. If you guys are ever worried, just be like, Victor, are you recording? And then go like this, and I'm like, yep, yes, it is. I don't want to close either of them because I'm too scared that I'm going to close the recording one. All right. So moving on. So now they want us to solve for this. So the only way to solve for this, aside from guessing, is we're going to do uh, ln. I know you guys are guessing. Don't tell me you guys aren't guessing. I see your guys' tutorials. Divided by log of 6. So I'm going to do log of 6. I get about 1.5-ish. So about this one. I'm going to do the same thing here, but now I'm going to do it with the 0.5 and the 12. So again, it's always log of the big number. In this case, that's 0.5. Log of 0.5 divided by log of 12. And I get this negative 0.27. So that's going to be here. And I think it's safe to guess that this is our last answer. Cool. So that method will always help you guys solve for logs. Um, that's one of the things that I like that Edmentum teaches you, is how to use it using a calculator like this. All right, so this new method is going to teach us about adding and subtracting. So basically, if we have a negative log, or I should say, if we have a log that's a fraction, what's going to happen is it's going to flip over here. So this one is a log when it's greater than 1. When it's bigger than 1, it's going to be increasing. When it's less than 1, it's going to be decreasing. And that makes sense because think of what logs are. Don't ever forget what logs are. Logs are opposite of exponents. So if you have a number that's greater than 1, you're going to have an exponential increase. But if you have a base that's less than 1, you're going to have an exponential decrease. So that's why these are flipping. It's going to be, if we cut that exponential increase, it looks like that. But if we're cutting an exponential decrease, So a decrease looks like this. It kind of doesn't change that much. Does that make sense? All right. And does it make sense? Let me use that. Let me use Desmos because Desmos will probably make it look a little better than how I did it. Let's say you had this uh, 0.5 to the x. So I'm doing like 5 to the x power. 5 to the x power. So it looks like this, right? See how it's decreasing? And then I'm going to have log base 1/2. So I'm going to do, where's the log button? Miscellaneous. Did you eat it? Oh, log base 0.5 of x. Yeah, Desmos drew it way better than I did. So if you see here, see how this is barely touching the y-axis? Well, our exponent is barely touching the x-axis. So our x and y kind of switch. So if I did something like this, it's a mirror. You're going to put, first of all, let me hide my keyboard. You're going to put this point ends up being like over here. So it's a reflection from here to here. So remember when you guys did geometry and you learned about reflection? That's what we're doing here. Does that make sense? So that's all that's happening. So because we're dealing with a fraction as a base, it kind of flips over how we're doing our logs. And then another way this is changes is if we subtract from the x. Remember, whenever we do any type of transformation, if we subtract from the x, that means we're going to move to the right. If we add to the x, it means we move to the left. And if it's outside, like let's say we have log base 2 of x plus 3, that means it would go up 3. If it was minus 3, it would go down 3. That's all this is saying right here, is that it changes the same way we would change parabolas. Remember when we had a parabola? If we changed our k, or if we changed our h, it changed our left and our right. If we changed our k, it changed our up and our down. Same thing. And then remember how we had an a? I have a feeling the next slide is going to be talking about what happens when we change the number in front of a log. 222. Oh, called it. So see here, what they're doing here is they're like, oh, if you make it negative, it's going to flip it over. It's going to flip it over, and it's also going to change how much it increases. So, for example, if we have a log like this, and then we multiply it by 3, well, multiplying by 3 makes it kind of look like this, and then making it negative means it's going to kind of like flip over and look like that. So that's what's happening here. Also, what's happening, actually, I'm not doing this justice, is the distance from here to the x-axis also increases. Let me kind of show you what that looks like on Desmos, just so you get a better picture of it. So let's say I have this. I'm just going to do a standard log base 10. All right. And let me erase this. Let me erase that. And then I do 3 log of x. What's happening here is, look, the gap between this increases by 3. So from here to here, it was a little bit, but then when we multiply it by 3, it becomes a lot bigger, right? It's still going to go over here to this 1. It still intersects at 1, but look at this big difference here. That's what's essentially happening. But also, I'm lazy, so I'm just going to copy and paste this. So I'm going to put a negative. The negative flips it over. But if I got rid of that, if I just had it as negative, see the difference between the two? Give me a second. Let me copy and paste this. It's the same idea. I know I have a lot of these, so let me just do that. So this is if it was negative log. It also increases the gap in between it. It still intersects here. And the reason for that is x to the 0 power is 1. So log of 0 is still going to be 1. Does that make sense? Cool. All right. So moving on. Next thing it talks about, I already talked about this. If you add to outside the parentheses, it just makes it go up and down. I don't think I really need to explain that much. The next one is, what is this one? Oh, they're combining them. So this is saying like, hey, look, we're gonna flip it over. We're gonna make it skinnier. So see how this one kind of has a curve to it, and this one's like really, really flat. That's because of this one half in the front. It made it skinnier. And also, you know what? I'm gonna increase it by 1. I'm gonna also make it go up 1. So by making it go up 1, it's no longer intersecting right here at 1. It made it go up, so now it's intersecting over here. Does that kind of make sense? If it does, let me. I'll go through it. I think we have enough time. Yeah, we have enough time for me to explain this. Let's say we had this negative log of x. So here's the negative log of x. I'm going to make it go up by 1. Plus, oops, no. Hit enter instead of plus. So what's happening here is it went up, which changed where this crosses the line. But because it was by a base of 10, it changed from meeting up at 1 to meeting up at 10. And guess what? That means that instead of 10 to the 0, we're going to get 10 to the 1. So that's how come this right here is a 10. Does that make sense? Because what's happening is instead of the x acting like a 0, it's acting like a 1. So that's how come the intersection kind of changed. Makes a little more sense. Another way of seeing this is like, let's say we go all the way here to 10. This will end up being -1. Basically, what happened is it was here at -1, but then we moved it up. Instead of being -1, this was 0. So that's another way of thinking about it. I think I made it a little more complicated going like, well, why did this change? It didn't really change so much as now it's up here at 1, comma 1. But by moving the intersection up, that means we kind of completely change what our x-intercept is. That probably makes more sense. I'm sorry. All right. So that's all that's happening here is we're going through a bunch of different changes here. If you guys are ever having doubts with this, like it's hard to keep track of all the changes, just mess around with Desmos and kind of like figure out what's happening. And what I like about Desmos is you can always turn off your older graphs to see how they're changing. You know what I mean? Like, adding 1, that just moved it up. When in doubt, graph it on Desmos. It really helps out. All right. So same thing with this. Let's say you had doubts on these. You could technically just graph all of these on Desmos. But what I'm going to do is I'm going to pretend this is just a regular log. And I'm adding 3. Okay, so I'm looking for a regular log that gets added to 3. So normally a log touches here, right? Right here at 1 comma 0. But if I'm adding 3 to the y value, I should get a 1 comma 3. So I'm going to look for 1 comma, not quite there yet. This looks like 1 comma 1.5. So that's a little interesting there. 1 comma. So this is the only one that really shows my graph going up. So I'm going to assume that that's my answer. So I'm going to grab this plus, oh, it's plus 2. That's why I didn't get this right. That makes more sense. So that was my bad, guys. For some reason, I combined this 3 and this 2, and I'm just kind of like mix them up in my head. This 1/2 means that the distance from the curve gets smaller. So at first, it might be like this, but when we cut it in half, that means it gets closer to that curve. And the only one I see here where I'm getting this closeness to it is going to be this one right here. The 1 comma 0 didn't change, so I'm going to grab this, move it there. And I'm going to look at this one. So this says I'm flipping it over and the distance is going to increase. So that one has to be graph 4, leaving this one to be that. And all that's saying is this went down by 2 and it also went to the left. So a few things happened to this one. It went, where's my pen? It went left 1 and it went down 2. So that's what's happening there. Does that make sense? Cool. And now we're going to talk about things like earthquakes and stuff like that on the Richter scale. On the Richter scale, earthquakes vary a lot, so they always do it by a factor of 10. So if you're talking about something that's a 2 versus a 1, 10 to the second power, that's 100 times greater. It's not 2 times greater because we're using the power of 10. It's 10 times, it's 100 times greater. So that's why they're comparing these two. This one was a measure of 7. This one was 6.5. So you're like, oh, this doesn't look that bad. It was almost 4 times greater. So even though there's not that big of a difference here because it's on the power of 10s, it makes a huge difference. All right, so let's move on to this next one. So this next one's gonna be, so we're gonna sketch this graph here. So here's the sketch of the graph. You may wish to graph using generic function if you'd like. So in other words, it's like graphing on Desmos. So here we're gonna talk about, so here's our graph, and it wants us to see what's our horizontal shift. Well, a horizontal shift is this part right here. What happens to the x? So this tells us -1. That means we're moving right 1. What's our domain? Our domain are all the x values at work. So remember, x is domain, y is range. So according to this, it looks like we never touch the 1. And that makes sense because we shifted to the right 1. So this is going to be x is always bigger than, where's my greater than sign on the keyboard? Oh, there it is, right next to the comma, or on top of the comma. Greater than 1. Our range, well, it looks like all the y values work all the way from -infinity to +infinity. So what I'm going to say here is I'm going to say all real numbers. All the numbers. All the real numbers. What's the vertical asymptote? The vertical asymptote is a line going up and down that we never touch. And we said that one was 1 because it shifted to the right 1. So I'm going to say that my vertical asymptote is x equals 1. All right. And is there a vertical shift? Well, we would have to see everything outside the parentheses. There is. It is going up by 3. So we go up 3. You're fine. Jeez. Actually, he's right. We would say, well, if we wanted to complete the session, we would say move up by 3. But he's right. You guys should use complete sentences. I had to take points off somebody's thing for grammar because they said something like uh, corresponding parts is equal or is congruent, and I'm like, it's plural. That's supposed to be are congruent. So I was like, it was really distracting. So I'm like, I'm just taking some points off because know your grammar. So thank you for pointing that out. I should say it correctly, grammatically correct. No, no, it's fine. Yeah, Graham, I did. I'm pretty sure he will. You want me to message him right now and see what he has to say about it? I mean, I'm not gonna be a stickler for it, but if what you're saying doesn't make any sense, then I'm probably gonna say something. So this is saying your x-intercept. Where does it cross the x-axis? Well, that's a little hard to tell because we went to the right. So normally this is our thing. But then we went to the right. Okay, so if we went to the right, this changed to, we went to the right by 1. Right by 1. So this changed into 2 comma, yep, exactly. But then we went up by this, by 3. It's like, wait a minute, but that's changing everything. And it's like, wait, this isn't an x-intercept anymore. Okay, well then let me go down 3 to go to 0. So if I go down 3, it kind of changes it. So it's really hard to calculate after a while. So guess what? When in doubt, go on Desmos. What were you going to say, Nick? Yeah. See what I mean? It gets a little confusing, so I'm just going to plug it into Desmos to make it easier for us. This is supposed to be a different type of log. I can't superscript that. How? Oh no. All right. So if we look at here, we will see that's really hard to calculate. So that's why Desmos is a good way of doing it. Another way of doing it would be to like set this equal to 0 and then calculate it out by, we're going to divide by 2. We're going to add the 3 or subtract the 3, divide by 2, base it. We can do all of that fun stuff, or we can just plug it into a graphic calculator. Um, However you want to do that. um, Next one, so just fill that out by going on Desmos. The next one after that, vertical stretching and shrinking, that's this number right here. So it looks like we're going to stretch this by a factor of 2. So we're going to say it's a stretch because it's bigger than 1 by a factor of 2. Find another point. Find y when x equals 9. So if we go on Desmos, we can just go to 9, go straight up, and we find that 9, I had it, 9 comma 9. So the y value is y equals 9. Or if you plugged it in here, it actually isn't, I don't think it's that bad to solve. So let me double check this. So this is 2 log of 8 plus 3. So 2 to what power gives us 8? Answer is 3. So in other words, 2 times 3 plus 3, that's 6, plus 3 equals 9. So that's another way to solve it. Did you guys kind of get what I did on that one? So it was a little harder because you have to know what power. So whenever you see this log, you just change it to what power. So that's where I got this 3 from. From there, you can solve the rest. Other than that, guys, I have no problem with you guys using Desmos to solve it. Yeah, if you want to screenshot Desmos, that'd be cool. I have no problem with that. That sounds cool. You can also save it if you have a Desmos account, like log in and save the graph. Either way, yeah. Yeah, if you want to show your work, then be like, I'll put it on Desmos. Here's my picture. All right, guys, and we're done with this module. Yay! So, if you guys haven't finished Unit 1, go on finish that Unit 1 up. Um, for this module, I'll have it due Thursday at midnight or Thursday at 11:59. I'll have this video up at the end of lunch. But yeah, we're done with the first module of Unit 2, guys. All right. And I'm going to